Chapter 10. This chapter deals with correlation and regression. This is going to be our last chapter for the semester. So there's a little bit of a reason for celebration, right? Correlation. What it is a statistical method used to determine whether a linear relationship between variables exists. So what I want you to think of is a couple of keywords in there is linear. One of them is linear. It's not a bell-shaped curve, and so I'm going to use our ruler example to kind of explain that. So what we did is you dropped a ruler, and as quickly as you could, you grabbed it, and we measured how many centimeters it took. Sorry, we measured in inches. How many inches it took before you grabbed it. And you notice that really quick reaction time and really slow reaction time was on the lower end. Most of you had that average reaction time of like 5 or 6 inches. Okay, so because of that, there was a curve, right? There were very few of you who could grab it really quickly, within like a half or an inch or 2 inches, and there were very few of you who it took 9, 10, 11 inches to grab. Most of you were, it took 3 inches, 4 inches, 5 inches, 6, 7, 8, right around there. That's how long it took or how far the ruler dropped before you grabbed it. So there was a curve to it. Really low in the beginning, really high in the middle, really low towards the end. This, what we're looking for is if it's linear, so a straight line. Always keep that in mind. Regression is a statistical method used to describe the nature of the relationship. So it describes what that relationship or what that line looks like. Is it positive? Is it negative? We're only dealing with linear in this chapter, but it could be nonlinear, like a bell-shaped curve. So regression just describes what that looks like. So we have a few questions that we want to answer in this chapter. Are 2 or more variables related? If so, what's the strength of the relationship? Things can be related to each other, but it doesn't mean that they have a high relationship to each other. What type of relationship exists, and what kind of predictions can be made from that relationship? So the first two, okay? The way that we answer those first two is using something called the correlation coefficient. And all that is it's a numerical measure that determines whether or not 2 or more variables are related, and it also measures how strongly they're related to each other. Okay, so again, correlation coefficient, that's one of the most important things from this chapter. Are things related to each other, and how strongly are they related to each other? What type of relationship exists? There are 2 different types of relationships, simple and multiple. We don't look at multiple, okay, so we're just going to focus on simple for this chapter. Simple relationship, there are 2 variables. Okay, this is pretty important to write down. Your independent variable and your dependent variable. The independent variable is sometimes called the predictor variable. It'll predict what will happen. And your dependent variable is called the response variable. Okay? So, for instance, I guess the way I always look at it and the way I always remember is that your dependent variable is the one that depends on what happens with the other one. Okay? For instance, okay, sorry, I had someone come in the room real quick. So for instance, independent, dependent. Let's say we were looking at how much your bill will be. No, let's do this instead. How much you work. Okay, how much your paycheck will be. The amount of money that your paycheck, if you work, the amount of money of your paycheck depends on the amount of hours that you work. So the 2 variables we're looking at is how many hours did you work and how much money did you make. How many hours that you worked, that's the independent variable. That predicts how much money you will make. How much money you made is the dependent variable because the amount of money you make depends on how many hours you work. Okay, so that's one kind of example. But you always have an independent variable and a dependent. The independent is usually the one that affects the other one. The dependent is the one that it is affected on. Okay, and that's why they call it the response variable. Okay. Again, don't worry about multiple relationships. What kind of predictions can be made from this relationship? Everything from weather forecasting, how much gas is going to be in a month, whether or not a team is going to win 10 games, 11 games, 12 games in the NFL, crops, how much will be sold in the next month. It is used everywhere in the real world in forecasting stuff, making predictions about the future. Okay. The thing is some of the predictions are more accurate than others, and that's obviously because sometimes the correlation or the relationship between those two is stronger than it is in others. And so we're going to look at what is strong, what is, how much can you actually believe, or how much can you trust the prediction. Okay. Visual representation of a bunch of data. So let's say you get a bunch of data. You ask a bunch of people, hey, how many hours did you work last week or in the last 2 weeks, and how much was your paycheck? So let's say you ask a bunch of people. You have two numbers for each person, right? You have how many hours they worked, how much money they made. We take that information and we create something called a scatter plot. Okay? Scatter plot is something that you've seen. It's just a graphical representation of your data. So we're going to use this data as an example. What this is how many cars were rented, car rental companies. So how many cars were rented and their revenue. So basically, how much money did they make? So we want to see does one have an effect on another? If you rent more cars, do you think your company makes more money? It would only make sense that you do, but does that actually happen? So here we go. We're going to use, this is in tens of thousands. So this is this is actually 6.3 million, or sorry, 630,000 cars. This is 290,000 cars. And this is going to be 85,000 cars, and so on. So we draw and label a graph with an X and Y axis, and then we just plot each point. It's as simple as that. So when you're doing that, make sure that the scale of your axes is correct. Just because this one goes up to 62.5 doesn't mean your Y axis has to go up that high. And then we just graph them. Okay? So here are the points graphed. That's a scatter plot. As simple as that. Okay? We'll use that in the future, but that's a scatter plot. If you want to see one more, here's another scatter plot. Okay. This time you see that the points kind of tend to go down. This was the number of absences a student has and their final grade percentage. There's your scatter plot for that. So you see it kind of gives a visual representation. It looks like the more absences that you have, the lower your grade is. Okay. Okay. So now we're going to be talking about solving for or finding this correlation coefficient. Important to remember, the values of the correlation coefficient have to be between -1 and +1. Okay. If there's a strong positive linear relationship, the value of R is what we use for that correlation coefficient. So make sure that you somehow show in your notes, R represents the correlation coefficient. If there's a strong positive linear relationship, and we'll talk about what that means, your R value will be close to +1. If it's a strong negative linear relationship, your value for R will be close to -1. Okay. So the closer you get to 0, the closer to no relationship you have. So we got a few graphs here, and this kind of shows you the difference between a positive and a negative relationship between variables. So you see right here, if we had an R value, a correlation coefficient of 1, exactly 1, this is what it would look like, a perfect straight line. Okay. If we have a little bit weaker, we still have, you can see kind of a line. It goes in the shape of a line, but you have points that are kind of scattered here and there. So that's an R value of 0.9. We get an R value even smaller yet, it's 0.5. You notice that the data is even more spread out. And the complete opposite when you look down here at your negative values. Really, really spread out is negative 0.5. Getting a little bit closer is negative 0.9. And a perfect linear relationship between each other is negative 1. Now, 0, if we were to look at 0, we'd basically be looking at a graph that was all over the place. We'd have points all over. There'd be some up here, some down there. You'd have your points all over the place. That would be something that's very, very close to 0. Okay? Obviously, that's not that, but that's what we're talking about 0, is that there's no really rhyme or reason. It's not like when you go further on the x, you go further up or further down. Okay? You just basically go all over the place. So how do we find that? Here's your formula for it. Looks ugly, doesn't it? Don't write this down. You are not going to have to use this formula. But it is important to understand a few things about it. Okay? If you look at this closely, what this is doing is it's basically measuring how far away from a line all these points are. Okay? So if we drew a line of best fit for this, and this is a horrible line, let's do better. I thought I could draw a line. Okay, it's not going to let me draw a line. But let's say we drew a line. What that formula basically does is it measures how far away all these points are. It measures the distance. And it finds an average distance, how far they are away. You see here, if we draw the line, the average distance they are away from the line is 0. Okay? Now, that works into the formula that makes it a value of 1. Okay? It's not like, think about that. It doesn't mean that the average distance is 0.9. Okay? That's not what it means. Okay? It just means that the closer it is to 0, it means on average the further these are away from the line. If I drew a line right here, again, a horrible line, but we start measuring distances, how far away they are from the line, you see they're a lot bigger. Because of that, it causes the R value to be closer to 0. So that's what the formula does, is it basically measures the distance they are away from the line. Okay? It is important right here to understand your rounding rule for this is going to be 3 decimal places. Okay, so 3 decimal places. So if we don't use this formula, how do we do this? That's the beauty of a calculator. So this is how you would do it by hand. Again, I told you we're not going to have to do this by hand. So what we are going to do is we're going to do it on your calculator. So this is what your R value should be, is 0.982. Okay. What I want you to do is if you have your calculator at home, do this. If not, do this when you get to class. I'm also going to have you do this. We're all going to do this together in class. Okay. But I'm going to grab your calculator real quick. So what you do is, the first thing we have to do is make sure that something called the diagnostics is on. And so you hit second, you go to catalog, and you arrow down and you find diagnostics, and you want to make sure that it's on. And you hit that, and it says done. Okay? Now what we do is we go into stats and we edit, and we're going to put all those numbers in. So the numbers are, oops, 63, 29, 20.8. $19.1, $13.4, $8.5. I remember, right? And then we go over here. We got 7, 3.9, 2.1, 7, 3.9, 2.1, 2.8, 1.4, 1.5. I'm not sure what's happening with my computer right now. Okay. 2.8, 1.4, 1.5. So now we have those in here. Hit stat again. Excuse me. Go over to calculate. Go down to linear regression. Okay. If your values are in list 1 and list 2, all you have to do is hit enter. But if you want to make sure, hit second list. You pick list 1, comma, second list, list 2. It is important the order that you put them in. Okay. You know, which one's your X, which one's your Y. If not, things could be flipped. And when you hit enter, here is your R value, 0.9819. And if you round that, that's 0.982, which we got right here by doing it the formula way. Okay? So that is your correlation coefficient. Now, what does that number mean? There's one more example, then we're going to skip over. Actually, I'm looking at the time of the video. We're going to stop you right there. Okay? We will talk about the rest of this. There will be another video over the weekend. And so right now, I'm going to go over that calculator thing tomorrow in class, but make sure that that is that you're able to calculate that. If you want to try one more, there's an example, 10.3 in your book. Plug those numbers in. You should get 0.067. Okay, you see that that's pretty close to 0, so that's a really weak relationship. Where in our last example, 0.982, that was pretty strong. All right, we will talk to you tomorrow.